Welcome back, class. Today we are going to discuss about the electrochemical series. Electrochemical series. And in this particular discussion, you will also find your answer the question which I asked in the previous video. So here is the sum of the hint, some of the clue in order to find the answer. So today is the 11/4/2020. What is electrochemical series? The first thing, the definition. So the electrochemical series is nothing but the arrangement. It is what? It is the arrangement. Arrangement of elements. So the arrangement of elements in order of increasing electrode potential. Increasing electrode potential value. So here the standard hydrogen electrode SHE is actually the reference electrode, which electrode potential is 0. So for 0 it can use as a reference electrode. So what is this order? I will write few of them. Although series is very long, so I will write just few of them so you can get an idea that how this order is written. So starting with the very first, F2 to F negative. Here is the F2, that means the gas. This will take 2 electron, and this is converted to fluoride ion, aqueous. And this is the value of electrode potential, that is the 2.87. So here I am writing the values of electrode potential. These are the element, these are the reaction, and this is the value. So this is the element, reaction, the redox reaction, and the E naught value. E naught, that indicating the standard value. Okay. So 2.87. Then cobalt, the second one, cobalt plus 3 to cobalt plus 2. Again the equation is cobalt plus 3 with release of 1, with getting 1 electron, reduce CO plus 2. So it has value 1.81. And so as the series is continuous, we have n number of element, and finally then this terms of hydrogen. So hydrogen H plus H2, that means the reaction is 2H plus with 2 electron will give you hydrogen, and this is the value of 0.8, and this is what the standard, this is what the reference electrode. Okay, in this reference we will take the other one. So moving ahead, Fe plus 3 to Fe plus 2, or Fe. So Fe plus 3 with 3 electron, this will give Fe. The value here, the value is in negative, just to know. Here the value is of positive, here the value is negative. So after hydrogen the value is negative. Then lead we can take, no need to remember actually all these value. I am writing the electrochemical series. Okay, whenever a question is asked to you, the values will given. On the basis of these values you have to solve the numerical. But I am writing the electrochemical series so that you will get an idea that what is the electrochemical series. So this again, this will continue with the several element, and I'm writing the last one now. The last one is the lithium plus to lithium. Here the values are of reduction potential value, no, you should know that. Li plus with the electron, this will give Li, and the value is minus 3.05. So what this says, from top to bottom, that means this is what here, it is strong oxidizing agent, strong oxidizing agent. So if this one is a strong oxidizing agent, what happened with this? This will be the weak oxidizing agent. And if strong oxidizing agent, this one, at the same time this will be the weak reducing agent. So here the value will be in opposite direction. So this you should remember. This is the weak reducing agent, and this one is the strong reducing agent. So lithium is the strong reducing agent or weak oxidizing agent. Fluorine is strong oxidizing agent and weak reducing agent. Got it? So this series is very long actually. If you go for the, it is given in your book, you can check it. The application part, which is very important, what is the need, what is the importance of this electrochemical series? So the application, the first application is prediction or predicting the feasibility of reaction, predicting the feasibility of reaction. That means if you have given a reaction, and on the basis of the values of electrode potential, how you will identify that the reaction is feasible or not. So let's take an example. If you have a reaction like copper plus 2 in aqueous media with 2AgS, this notation is very important. In electrochemistry you have to write the notations, the medium, okay, S and 2Ag plus with aqueous. Now the question is whether this reaction is feasible or not. So we have value as per the table. This is the table. If you go for the complete table, you will get the values of copper and silver also. So I am writing the value here. The E naught value, E naught is the standard value, the EMF value or electrode potential value of copper is plus 0.34 volt, and for that silver it is plus 0.80 volt. So what it says that since the electrode potential value of silver is greater, electrode potential value of silver is greater than copper. So what will happen? Silver has a greater tendency to get reduced. So silver has greater tendency to reduce. So what it does mean? It means the silver will be reduced and copper will be oxidized, because vice versa is there. But the reaction says that copper is reducing Cu plus 2 to Cu, and silver is oxidizing, but the values as per the electrochemical series electrode potential value shows that silver should reduce and copper should oxidize. So on the basis of the values of electrode potential, we can say that the above reaction is not feasible, is not feasible. Although reverse is possible, reverse is possible. That means copper s 2Ag plus, so this will give copper plus 2 and 2Ag. This is possible. Okay, this you can write, but this is not possible. So this is how what the first application of electrochemical series. Now the second application. Second is to predict whether a metal can liberate hydrogen gas from acid. So this is the second application, that if you have a metal and you want that whether this is applicable to release the hydrogen gas, this also we can explain on the basis of the electrochemical series. As we all know that there are several metals like zinc, magnesium, and the nickel. These are the metals which can easily liberate hydrogen. These metals liberate hydrogen. But what's about the copper, then silver? This case hydrogen liberation is not possible. So what is the reason actually? So reason is very clear. Only those metal can liberate hydrogen from the acid which have a negative value of reduction potential. Only those metal can liberate hydrogen which has negative reduction potential. Reduction potential. So any metal which has negative electrode potential, it will liberate hydrogen. Actually what happened in this case, see, we have a metal, this will convert it into ion by release of electron, and this electron is taken by the hydrogen aqueous, and this will give the hydrogen gas H or half H2. So this is what the mechanism takes place. So any metal which is capable to release electron, and those metal, only those metal capable to release electron which has the negative value of reduction potential. So we know that the copper and silver has a positive electrode potential. Copper and silver have a positive value of electrode potential. So as they have reduction potential, you can say, or E naught, as they have positive value, that means it is not capable to release the electron, and if it is not capable to release electron, hydrogen gas will not liberate. Okay, so this is what the reason. Only those metal can liberate hydrogen which has a negative reduction potential. In case of copper and silver, they have positive value of reduction potential, so they will not release hydrogen gas. This is what the reason. So this is all about from today's lecture, and I hope you're able to find the answer of the question which I asked you earlier on the basis of this discussion. Your answer is in this discussion, so go for that. Thank you so much for your watching.